So the first thing to emphasise, of course, net zero isn't sustainability. It is a component of sustainability, and we must never forget that. To deliver sustainable farm systems, we need to concentrate and deliver on the 3 pillars. And anyone who's heard me speak has seen me use a version of this slide, but it's really important that we emphasise this to the farming community, that as we move towards net zero, we mustn't forget about the other aspect of sustainability. These need to be delivered in concert. And the first component around societal need, especially with the feedback of the National Food Strategy, we need to deliver food that delivers human health, not metabolic syndrome. Agriculture and agricultural land use needs to be the health industry, driving food systems that drive human health, reduce the need and the requirements for NHS, and drive people to live long and healthy lives, not metabolic syndrome. So we really need to address the types of foods that we are producing and how we consume those. Second need is around economics. The agri-food sector is the most important sector to realise solutions for the future humankind. To feed a growing population without destroying the planet is the biggest challenge that's ever faced humankind. So how are we going to deliver that? We need the best brains, we need entrepreneurs joining the sector to realise new ways of farming. Not to farm as my father farmed or my grandfather farmed, but to change how we consider thinking about different components. Sophie talked about the blueprints, and she was right. There are no single blueprints. It's about farming systems which are right based on your farm, your location, your resources available to you. And we need to drive those entrepreneurs, those businesses, to drive income, which makes the next generation want to study at Harper Adams and affect the agri-food sector for the better. And then finally, the third need is, of course, is environmental. Whilst delivering a product that society needs and drives human health, drives profitable businesses, which encourages the future generations to be part of a sexy agri-food sector, we need to be the first generation that leaves this planet in a better state than we found it. And that's, of course, what we're talking about today around net zero. But it's not solely net zero. This is some work that we did looking at trade-offs and different metrics of sustainability that every farmer has to consider. So this is an example for a beef farm. And you'll see an awful lot of those are focused on metrics that farmers fully understand around profitability and efficiency and carrying capacity and nutritional value. But of course, we also need to consider greenhouse gases, sulfur loss, nitrogen loss, phosphorus loss, animal health, biodiversity on our farms, input costs, output costs. All of this, the farmers need to consider whilst we're moving towards sustainability. And it's complex. And this is one of the biggest issues that we have in drawing a roadmap for the farming community, is you're not just concentrating on a single metric of carbon. We have to consider all of these in concert. And that's why we really do need the sector, we need government and policy to come together to realise these solutions. And I'm delighted for the support that Morrisons, the NFU and McDonald's has given to Harper Adams in driving the School of Sustainable Food and Farming forward to help the sector realise these solutions. So it's not just net zero. I really want to emphasise that. But of course now, as I said, this conference is about net zero and realising solutions. We have to be aware that agriculture is a significant source of emissions, and it's 10% of UK annual greenhouse gases. And I hear this kickback sometimes saying, well, yes, but we're not the biggest sector. We've got energy and transportation, which are larger emitters of greenhouse gases. Yeah, but however, we need to remember, of course, these sectors are decarbonising. They're moving away from fossil fuels as they should. They're moving towards sustainable energy as they should. But of course, then the eyes of Mordor on the greenhouse gas emissions will be more focused on agriculture, because
we are in the carbon game. As Sophie already rightly said, it's how low you can go, and then we sequester the emissions that we can't mitigate. But we are in the carbon game. We are growing carbon to feed carbon. So we cannot decarbonize. So it's about a focus on efficiency and then a focus on sequestration. I'm going to concentrate on livestock because that is my background. And there's obviously been a big discussion around methane and nitrous oxide emissions and how we're going to tackle methane within the livestock sector and realise that COP26 requirement for a 30% reduction in methane. And I warmly welcome that challenge from COP26 because I think that's a key focus for the livestock sector to be realised, and it is achievable. So before we start going into the nuances of the work around how we realise a net zero livestock sector, I just thought it's really important. I know I'm teaching grandmother to suck eggs at here a little bit, if you pardon the pun, but we've got just to emphasise the importance of the livestock sector, and that is really critical, especially when we're looking at the National Food Strategy's response. And I'm delighted to see there was a pivoting from government in supporting UK production. And I think the Ukraine crisis has really emphasised a focus around national food production, high quality local food production as being the bedrock and the backbone to national food systems. There has been a pivoting back to onshoring, but we still need to realise, of course, that Green Deal and realise that reduction in greenhouse gas emissions. So approaches to net zero. This is what all farmers are fully aware of, how we improve efficiency on farm. And I think it's really important to emphasize that the first steps toward net zero are exactly that. It is about doing everything a little bit better and focusing on efficiency. And the first starting point is to look at the animals, and as I said, I'm going to focus on the livestock systems and particularly ruminant systems in this talk, focusing on genetics and focusing on health. So the first component is how productive are my animals? How healthy are the animals? And a move towards on that sustainability agenda has to be a discussion with your veterinarian to make sure that you have the healthiest animals. You can only improve on nutrition, you can only improve on genetics if your starting base is healthy. So that's the first component. Then we need onto nutrition. And again, my background is rumen biochemistry. It's where I'm happiest talking about total mixed rations, balancing of nitrogen energy to realize high quality microbial protein. We need to have that focus on homegrown feed and really good rations to drive animal performance. And then there's some work that's been done on supplements, and I won't steal Sharon Hughes' thunder talking about archaeal suppressants and the work that's been done at Queen's, but there are other supplements that have been in development, but they are only additive in terms of what we can do. The first focus has to be on performance, productivity and efficiency. That's the low-hanging fruit to realizing that journey to net zero. The third area is around sequestering that carbon that we can't mitigate through improvements in efficiency. And I'm going to talk a little bit more about that for the rest of the talk on nature-based solutions, soil, forage, woodland. And then finally, on farm, there needs to be a focus on energy, reducing energy use, reducing fossil fuels particularly, but also creating energy, green energy on the farm, whether it be through AD, whether it be through solar panels, or whether it be through wind generation. So the first components, and you'll see when I mention around sustainability and the three pillars, central to that was soil health. Because to realise a sustainable food system, we need to wean ourselves off expensive inputs, both economically and environmentally, and drive biological solutions on our farm to realise biomass production. Whether you're an animal producer or a livestock producer, realising biomass production to drive feed and food. And of course, to do that, it's getting biology and soil chemistry and soil physics to work with you. This is some work that which we did at Rothamsted prior to my arrival at Harper Adams. I led the largest research project called Soil to Nutrition in the UK. £8.5 million invested around soil health. So this is some of the great findings that Professor Andy Neal did within that project, trying to understand what drives soil health. On the left-hand side, you'll see some X-ray tomographies, X-rays of soil. We all know that grassland soils drive better biological biomass production than more degraded arable soils. So what is driving that? And then how can we take that knowledge to improve the soils and to reduce the amount of inorganic inputs within them? And what Andy showed is that some of the key metrics is not just about the soil pores. So the red spaces that you can see in those X-rays are around air spaces, pockets. And the cartoon next to it, you'll see it's not just about the size of the pores, it's also the size of the connections, what we call connected porosity. And this indicator decrit basically gives you the size of those pores, those connections between those pores. And that's really important because you're seeing the central graph, connected porosity is related to hydraulic conductivity, i.e. how easily water and oxygen can move through the soil. If you think about the soil, think of it as your lungs. The better the oxygen can move through your lungs, the easier you can get to drive health. And that's no different with soil. We need oxygen and water to be able to move through that soil and drive microbial interactions. The graph on the right actually shows that matric potential, how wet or dry a soil is related to anoxic proportion. And the grassland soils can hold more water and be and still have oxygen. They will not be anoxic than degraded soils. So degraded soils will be anoxic under drier conditions. So grassland soils can hold more water and still drive oxygen movements through it. And what's driving that is organic matter. Soil organic matter is critical to that. And that's data from 175 years of the long-term experiments at Rothamsted. So aligned to that, we also did some work to have a look at where the soils, what was the state of our soils within the UK. So the graphs on the left of the screen look at 40,000 soil cores that we did across the UK, trying to determine how healthy those soils were. And the amount of carbon a soil can hold relates to the amount of clay within that soil. So using a ratio of soil organic carbon to clay, we can determine how well that soil is holding its carbon. And the upshot of this showed that 40% of our arable soils are degraded, i.e. they could hold more carbon, but that carbon is missing. Grassland soil is about 77% degraded and forest about 6%. So our grassland soils are as healthy as our forest soils. So how do we turn our arable soils into our grassland soils? And of course, a degraded soil doesn't mean it can't produce biomass. It just needs more chemistry. It needs more inorganic inputs. And more inorganic inputs drive carbon emissions. So how do we get our arable soils to be similar to our grassland soils? And the answer is shit, organic matter. Increasing the amount of soil organic carbon within the soils is a way that we drive soil health. And this Polton paper published in 2018 summarized all the data from 175 years of the long-term experiment, showing that the best way to turn health back to soils is farmyard manures or grass after arable. So integration of livestock back into arable systems will drive that soil health and reduce our reliance on inorganic fertilizer. This is why the messaging around life without livestock in a sustainable planet is so wrong. They are critically needed as part of that circularity. All we need to do better is to realize how we can take our brown gold, convert it and valorize it into ways that can be used in different arable systems. Easy task. This is an experiment as well, which we carried out at Northwick, just to show the impact of land use change. but land use change a little bit different than converting forest into grazing pasture, which we hear so much about in the Amazon. But this is about conversion of grasslands in the UK into arable. And this is an experiment from Rothamsted at Northwick. And these hydrologically isolated fields, just showing the vast loss of suspended sediment, carbon, and nutrients from a field that used to be grassland into an arable field. So that's the orange bars that you'll see. You can see the difference of the water from one storm event coming from those flumes, this chocolate milkshake on the left and this whiskey coloured on the right, and you can see the green bar at the bottom. So the retention of our grasslands is absolutely critical to realisation of sustainable food and the environment. And we need to protect our grasslands. And the best way, of course, of protecting our grasslands is to protect rural communities that utilise ruminants for high quality protein production. Okay, so how do we improve the system? So these are some examples of some research that I've been involved with. First of all, focusing on homegrown feed, the realisation and the importance of legumes, some of the great work that's happening at IBERS in Aberystwyth, looking at different clovers which are being bred. Stoloniferous red clover is extremely exciting. So, and to remember that every mole of nitrogen fertilizer that you put on your farm, you're putting 6 moles of carbon into the atmosphere. So focusing on reducing fertilizer use and better utilization of legumes within your systems. This is a postdoc of mine, Graham McAuliffe, who's now leading some of the research at Rothamsted. And his work also showed that it wasn't just a reduction in fertilizer that clover was having an impact, but the root exudates driven from a more diverse sward, particularly when you had clover within that sward, was affecting the microbial communities and reducing nitrous oxide emissions. So it wasn't just about reducing nitrogen fertilizer going in, it was also about root exudates improving nitrogen flow into the forage. I won't spend so much time on this. Again, an awful lot of work has been done at looking at traits within grasses. I'm sure you're all aware of the high sugar grass work, improving nitrogen use efficiency, but also looking at digestibility, which will reduce methane, and the importance of thinking about multifunctional swards within our pastures. And I like to use the term multifunctional instead of multi-species, because functionality is critical within our farms. We need our forages to also produce live weight gain as well as produce biodiversity, soil health. So it's about selecting those species that really delivers to functional sustainability. Hedgerows and tree management, there's been a lot of talk about the potential of trees and hedgerows to drive carbon capture. So we did a little bit of modelling at Northwick, and this was with a colleague and friend, Dr. Takahashi, who did some analysis looking at how much trees would we have to plant on this farm in Devon, a 20-hectare farm, to offset the emissions from these cattle. So if you follow the modelling through, 20-hectare farm, 1.5 livestock units per hectare, 30 finishing suckler cattle, finishing about 600 kilograms of live weight, how many trees would we have to grow? So on the x-axis is the live weight produced from the farm, and on the y-axis we've got the emissions in kilograms of carbon dioxide equivalents. So this is our baseline here. And then this is 10% of the pasture converted to woodland, 20%, 30%, 40% woodland. We've offset all our carbon. Great. We've probably put the farm out of business, but we've certainly offset all the carbon. And if we go to 50% woodland, we're in net zero. So, of course, we've got to be realistic. You know, the farm's going to make a profit as well. So where is that sweet spot? So the other thing we modelled was about productivity improvements. Farms aren't status quo, they're not stationary, they are improving all the time. And as I said, the first 2 aspects of any net zero strategy has to be on performance. So let's model in this current increases in productivity, 10%, 20%, and a 30% increase in productivity. And if you follow this through, you get a sweet spot of a productivity improvement of 20%, and a woodland cover of 20% may result in a 30% reduction in greenhouse gases with a 90%, 96% retention and productivity. So this sort of analysis is what we need to do to support the farming community when we're realizing what's possible on their farm. As I said, this is one farm, one example in Devon, but finding that sweet spot to balance tree plantation, carbon capture, hedgerow maintenance to help drive is part of the solution. There we go. Okay, I now just want to give you a bit of a snapshot of some of the work that we've been doing at Harper Adams following this model. So as you probably heard from Ken, we've made a commitment at Harper Adams University to be net zero by 2030. But we've also got a huge farm that runs through our university, which is a major benefit for Harper Adams. But also when you're making a net zero commitment, it can be a major challenge. So what we've said is, okay, we will make a net zero commitment for our farm and campus. And how are we going to realize that net zero? So the first thing to do, as I'm sure you're aware, is to benchmark. We use a whole array of calculators at Harper Adams. So I'm just giving the AgriCalc data. So we ran an assessment of our Harper Adams farm and found out we were about 5,000 tons of carbon dioxide equivalents associated with our farm. So that's our starting point. And every 12 months, we will run a similar assessment and seeing how far we're going. So first of all, concentrating on NPP, net primary production. What have we done already and how we are moving towards that net zero? Remember that this is part of the mechanism. I'm not talking about the genetics improvements or the feed improvements and the animal health improvements, which of course have to be run in concert with this. So 38 hectares of woodland here at Harper Adams, 18 kilometres of hedgerows, which are restored, 4.5 kilometres of new hedgerows, and another 0.8 kilometres planned. So we've calculated that we've sequestered about 413 tonnes of carbon dioxide. So we've taken it below 5,000 already. Also, we've got a real focus on reducing our fossil fuels. We're lucky here at Harper Adams to have engineers and work on electrification of the farming sector, hydrogen power in our tractors, and of course, autonomous vehicles as exemplified by Hands-Free Farm. So how low can we go in reducing fossil fuels use is critical. Also, a major focus on soil, as you probably guessed from my starting gambit. We need to move away from complete inversion, keep that carbon in our soil, and have invested in direct drilling. Here you can see Stock Kirby, our farm manager, very happy with his Claydon drill here, and looking at how we can improve soil health through these interventions. And we've calculated through improving and focus on soil, we've reduced about 1,074 tons of carbon dioxide equivalent saving, but just concentrating on better soil health strategies. Also, a huge focus on integration around soil crops and livestock. You know, these little woolly things here in the middle, they're going to have a role in lowland farms. It's not just about producing high quality protein, it's about making arable farms more resilient, reducing fossil fuels, better integration, and driving soil health, allowing farms to have cover crops, less bare soil, which is disastrous. Also, the farm's done a phenomenal amount of work on maize. We all know maize can be, we all know maize is a great feed for high yielding dairy cows. Clearly is. It's got a really good balance. However, equally, it can be a disaster for the environment on the wrong soil types, on the wrong topography. Basically, it's just a free rein to lose soil and nutrients into river or into roads. So how do we improve the sustainability and the efficiency of maize where it's pertinent to grow it? So we know all the issues with maize is about bare soil, so integrating of grass with maize. This is a project looking at alfalfa and maize, and I'm delighted with the amount of great Lucerne alfalfa work that we do here at Harper Adams. I think we're leading in this, and all credit to Scott and the team for the work that they've done on alfalfa, which is a fantastic crop in terms of nitrogen use efficiency. And this work here is looking at chicory integration with maize, and also I'm sure you're all aware of the benefits of chicory in terms of anthelmintic use within sheep systems. So integrating and cropping is work here that we're doing at Harper Adams. And a huge focus on forage. I'm sure you're all aware of Liam Sinclair's great work over numerous years improving dairy rations. So continuing that work, we're investing in silage research here. We just had a postdoc join us in silage microbiology, and that's critically important, the work that Kate's doing, but also linking with other partners. As you know, anyone who knows me knows how excited I get about red clover. I think it's a fantastic forage, but obviously one of the issues, of course, is its persistency. So how can that be improved and integrated to drive better diets? And finally, a focusing on energy. I've mentioned this before, making sure that we utilize our farm to produce green energy and capture carbon, whether that be AD, solar panels or wind. It's a critical component of realizing net zero within the agri-food sector. Sophie's already talked about the School of Sustainable Food and Farming. I know over the next 2 days, and I'm gutted I can't be there with you. You're going to be talking an awful lot more about the School of Sustainable Food and Farming. Please, if you have any questions, I'm sure Simon will be able to address those. So do ask and get involved within the school. We need more and more farmers exemplifying best practice, because that's how we're going to drive the school moving forward.